Let's take a sneak peek at 3 scientists discussing their favorite targets. It'll give you a chance to decide which one is your favorite.
Hi, my name is Bridget Hessman. I work at the University of Maryland, and I'm based at Goddard Space Flight Center working on one of the instruments on Cassini called SEERS, where it's a spectrometer that looks at Saturn's atmosphere and determines its temperature and composition. So I spend a lot of time studying weather on Saturn.
I'm Zibby Turtle. I'm from the Johns Hopkins University Applied Physics Laboratory, and I work with the camera on Cassini, studying primarily Titan, its surface, the lakes and seas on its surface, and its weather, the big rainstorms that we've seen from time to time on Titan.
My name's Carl Murray. I work in the astronomy unit at Queen Mary University of London, and my interest is in rings. I'm a member of the imaging team. Rings are essentially all composed of little small satellites, and they move around Saturn. So I'm interested in the way they move and how they interact with the icy satellites, the big ones, the small ones. So that's what interests me.
Okay, so we need to discuss the different observations coming up to figure out which one is the highest priority to choose between them, because we don't have infinite resources. So you have a Saturn observation.
Mm-hmm. Yeah, so we have a Saturn observation where we're going to be going over top of the North Pole of Saturn. And when we go over the north, we're going to take a lot of camera images with a wide camera and a narrow camera, where we're taking a look at this really neat feature called the hexagon, which a lot of people don't understand because it has this 6-sided feature that just looks like it's standing there. And they're trying to understand the wave-like nature of the hexagon. In addition, at the very pole, some of our colleagues have discovered a beautiful hurricane right at the pole of Saturn's north just recently. We want to get some more narrow images to try and understand the cloud depths and what's going on in the hurricane.
Is this a kind of unique observation? Will you get another chance to do this? Or?
The inclined orbits are coming to an end.
Because Cassini's in a tilted orbit right now. It's
Cassini
not down in the equator.
Not going right along the equator right now. It's going up and over the poles. We won't do that for very much longer. And without these type of images at this point, we won't necessarily get another good view.
So for the same reason, because we're approaching over the high northern latitudes, that's exactly the same reason why this is such a good time to look at Titan. Because for Titan, it gives us a view of the North Polar region, which is the region on Titan where we see lakes and seas of liquid hydrocarbon on the surface. And we don't see those anywhere else on Titan.
And what are those images going to show you about the lakes? Are they going to show you what they're made of? Or are they going to show you how big they are? Or are you going to be able to see if they've changed?
Yeah, so the observation we have planned, we'll take the camera, we'll take a mosaic of almost the entire disk of Titan that will show the high northern latitudes, and that will show us the locations of the lakes and seas, their sizes and their shorelines. The spectrometer will also be taking data at the same time, and that will give us compositional information about the surface and about the lakes and the seas.
That will tell us what it's made of.
That will tell us what it's made of, yes. And then the camera images and the spectrometer images will be able to tell us the shapes of the lakes and the seas. And one of the things that's very important is to see if those change over time. So at the very end of the mission, as planned, we'll have another chance to look at the high northern latitudes. And given 3 years in between, we'll be able to see if they've changed, if anything's changed on the surface. And things may well change on the surface because as summer is approaching, Titan's atmosphere is heating up at the high northern latitudes, as Earth's does in the summer, and we expect big storms to occur. Storms with methane clouds and methane rain pouring out onto the surface, flooding the channels that we see on the surface, eroding the channels, and flowing down into the seas and the lakes. So this observation of Titan is important because it gives us something to compare an observation a few years later too. We haven't seen any storms yet. All the computer models actually predict that we should have had storms, but predicting weather on Titan is apparently just as hard as predicting weather on Earth.
Like all the storms are on Saturn.
Yes, clearly.
And on Saturn.
All our storms are on Saturn right now.
So we haven't seen any storms yet. This observation would give us a good before picture of Titan's North Polar region. to compare if we get storms between now and the 3 years from now, when we'll have another opportunity to look at Titan. And then we can compare those observations and see if anything's changed, and see if 3 years from now we see rivers flowing on the surface as opposed to empty river channels.
Okay. Well, I think we should be looking at rings. Saturn's the ringed planet after all, and the strangest ring of all is this F ring just outside the main ring system. We saw with Voyager, it's just bizarre.
What makes it bizarre?
Good question. That's one of the things we want to understand, which is why we should be doing the ring observations. Partly it's due to there's a moon either side, Prometheus and Pandora, and they have a gravitational effect on this ring. And we think they're also exciting. There's objects we can't see, sort of like a dark matter at Saturn, things we can't see, and they're getting excited and they're colliding with the core of the ring, producing these jets. And so that's
jets
why
of ring material coming
jets
off the
of
rings.
ring material. Some of them are kind of small, as we call these mini jets. Other quite large ones, several hundred kilometers, going out from the ring. So we want to understand this because these are collisional processes going on, objects colliding, like real sort
They're all
of
bumping into each other.
all bumping into each other, and it's almost like sort of fender bender velocities. So we'd like to see that, and there's kind of no wasted image of the F ring. It's just so bizarre wherever you're going to look. And we've got a special, just like you all got special observations. Our one is we're going to stare at one side of the rings and essentially just stare and wait for the material to come underneath us. The one thing we don't have is weather, so I think we're lucky in that respect. I think we could just do without any weather. So
Weather is
that's
very
fine.
complicated. We all need to try and understand it. That's why we have to really focus in on the North Pole of Saturn and try and understand what these storms are doing, and why do we have a hurricane at a pole.
And with Titan, the models that we use, the computer models that we use to study Titan's atmosphere, are models that have been designed to study Earth's atmosphere. And if we can apply them to Titan's atmosphere and predict Titan's weather, then that tells us that the physics that's in the model is correct. So these observations of Titan, if we see clouds starting to form, which we expect it may happen as northern summer comes to Titan, then we use those as tests of the computer models. So right now there's a big question mark why we haven't seen the clouds yet. So that's one of the reasons that observing Titan right now is very important.
I was going to say with the F ring, we had a situation where the modelling actually came first. The modelling was able to predict structures that were being produced by Prometheus dragging out material. And we looked at all the Voyager observations and never saw anything like that. But the model predicted they should exist. And then when Cassini gets there, we see them, which is a big tick for modelling, You're able to predict that these things existed. But we're learning. There's still things we don't understand.
Now you've had a chance to see what passionate scientists think about their favorite targets. So read up, learn about them, and pick your favorite. We look forward to reading your essays.